Welcome to today's Explainer. Look, if you've ever felt totally overwhelmed by all the technical jargon surrounding artificial intelligence, you are in the exact right place. Seriously, today, we are completely dropping the gatekeeping. You need absolutely zero programming experience, no math degree, nothing. We're going to build your understanding of AI from the absolute ground up, taking it one easy step at a time.
Let me kick things off with a quick question for you. Are you using AI right now? You might immediately think, well, I haven't opened up ChatGPT today, so probably not. But I challenge you to look just a little bit closer at your daily routine.
Because the reality is, you interact with incredibly complex AI systems multiple times a day without even realizing it. I mean, when Face ID unlocks your phone, when Netflix or YouTube recommends exactly what you kind of want to watch next, when Google Maps dynamically predicts your traffic route, or when Swiggy estimates the exact minute your food is going to arrive, that is all artificial intelligence at work. You already have a super strong practical connection to this tech. Now, we're just going to understand the mechanics beneath the surface.
Okay, let's dive into this. Here is our visual roadmap for today's explainer. 1. Decoding artificial intelligence. 2. The machine learning path. 3. Inside deep learning. And 4. The generative AI era. We're going to climb this technical mountain together.
All right, step 1, decoding artificial intelligence.
So artificial intelligence is, at its core, actually incredibly simple to define. It's really just technology that allows computers to perform tasks that typically require human intelligence. Think about what we do naturally as humans, right? We recognize patterns, we understand spoken language, we look at a picture and instantly know what's in it. When automated traffic cameras look at a car's number plate to issue a challan, or when Siri understands the context of your voice command, that's just a machine mimicking a basic human ability. It's not magic, it's just machines being trained to process the world a little bit more like we do. Moving right along to step 2, the machine learning path. This is the most important subdomain of AI, where the magic of data really happens. And this brilliantly illustrates the biggest foundational shift in how we program computers. See, in traditional computer science, a human programmer writes the rules. You give the computer an input, you give it the human-written logic, and it calculates an output. But machine learning entirely flips the script. There is no human writing the rules anymore. Instead, you give the computer the inputs and the desired outputs, and the machine figures out the logic all by itself. It literally learns the rules directly from the data. Let's demystify how this algorithmic process actually works using a simple bank loan analogy. There are 2 main phases here. Phase 1 is training. Imagine a bank looking at thousands of past loan applicants. The machine looks at their profiles, those are the inputs, and sees who was approved or rejected, the outputs. By studying all of this, it learns the patterns and forms its own logic. Then comes phase 2, which we call inference. A brand new applicant walks into the bank. The machine uses that logic it just built during training to make a prediction, deciding whether to approve or reject them right on the spot. So training builds the logic and inference puts it to use. Now, machines can learn in a few different ways, and we categorize these into 3 main types. First is supervised learning, which is kind of like using flashcards with the answers on the back. We give the machine perfectly labeled data, like marking thousands of emails as spam or not spam, so it learns to filter your Gmail. Second is unsupervised learning. Here, we give the machine completely raw, unlabeled data and just let it find hidden patterns on its own, like grouping thousands of random news articles into logical categories. But the third one, reinforcement learning, is super fascinating. Think of this exactly like training a pet dog. You give a command, and if the dog sits, it gets a treat. If it doesn't, no treat. The machine learns through a system of digital rewards and penalties, continuously optimizing its actions to maximize those rewards over time. Okay, let's look at this simple equation, y equals f of x. And please, do not let the math intimidate you here. In supervised learning, specifically a process called regression, all the computer is doing is finding a mathematical relationship between 2 things. Imagine trying to predict someone's weight based on their height. You plot the data on a graph and draw a straight line through it. X is the input, like height, Y is the output, the weight. The machine is literally just trying to find the best mathematical function, that straight line, to connect the 2. And that's the whole shebang.
Awesome. You made it to step 3, inside deep learning. So, the crucial point is that standard machine learning is fantastic for neat rows and columns of data, like a spreadsheet. But it really struggles with raw, messy, unstructured inputs, like the pixels of a YouTube video or the audio waves of a phone call. To process that kind of chaos, we had to copy the ultimate processor, The human brain. Enter neural networks. These are complex algorithms made of interconnected artificial neurons designed specifically to extract deep meaning from all that raw, unstructured data. Training one of these neural networks happens in a highly intuitive two-step loop. Step 1 is forward propagation, where the network takes the data and makes a guess at the answer. Step 2 is backward propagation, where it calculates exactly how wrong its guess was and then works backward to adjust itself. Think of a college teacher trying to design the perfect grading system. They might initially give midterm exams a 40% weightage and class tests 20%. But then, they realize students are skipping class tests. So through trial and error, they adjust those weightages, maybe making them equal until they get the perfect student attendance and CGPA calculation. That constant trial and error adjusting those weights of importance to get a more accurate result is exactly how a neural network learns from its mistakes. Because the world has so many different types of data, we've actually built different architectures to handle them. Let's do a rapid-fire breakdown. First, feed-forward neural networks, or FNNs. These are your standard straight-line prediction models. Next, recurrent neural networks, or RNNs. These actually have a form of memory. They're perfect for sequential data, like translating a sentence or predicting stock prices, where what happened in the past really matters right now. Then we have convolutional neural networks, or CNNs. These are your visual experts. They look at data in grids, making them perfect for recognizing faces in images or videos. And finally, transformers. These are the models that understand deep context and attention within massive amounts of data. They are literally the powerhouse behind the modern AI revolution. Which brings us to our final destination. Step 4, the generative AI era. Generative AI represents a massive game-changing shift in capability. Up until this point on our roadmap, the AI we discussed was primarily about analyzing existing data, right? It was predicting a delivery time or detecting a spam email or maybe classifying an image as a cat or a dog. But generative AI creates something from absolutely nothing. It is the subset of deep learning focused on generating entirely new text, brand new audio, hyper-realistic video, or beautiful images that have literally never existed before. Let's move to and see how this builds by untangling some heavy jargon you've probably heard lately, NLP and LLMs. So NLP stands for Natural Language Processing. This is the ultimate goal, the field of teaching machines to interpret, understand, and generate human language. LLMs, or large language models, are the powerful engines driving that goal. They are massive neural networks trained on vast oceans of internet text to actually solve those NLP tasks. Simply put, NLP is the destination we want to reach, and LLMs are the powerful vehicles taking us there. Right now, there is just an incredibly vibrant landscape of tools available for you to go out and use today. We've categorized them cleanly here by output type. For text generation, you have world-class LLMs like ChatGPT, Google's Gemini, Anthropic's Claude, and Meta's Llama. If you need stunning images, tools like Midjourney, Dolly, and Stable Diffusion will paint literally whatever you prompt. For video, mind-bending tools like Sora and Runway are totally changing the film industry. And if you want to write software without being a coding expert, GitHub Copilot will generate the code right alongside you. Well, we have climbed the entire mountain today. You started at the basic definition of AI, moved through the data-driven logic of machine learning, explored the brain-inspired networks of deep learning, and finally arrived at the creative power of the generative AI era. You went from zero to a complete foundational understanding. So I'm going to leave you with this empowering question. Now that you actually understand how these machines learn, adapt, and create, what will you build with them? Thank you so much for joining me on today's Explainer. Stay curious, keep learning, and I'll catch you in the next one.